So today we are going to tell you a bit about our experience working on the open calls and challenges for the last 2.5 3 years. We have organized a series of open calls and public challenges aimed for bioimage and deep learning communities. So we will talk in length about what they were and how many interesting lessons we learned from it. And hopefully it will be interesting to you, and also you'll learn something from our our experiences, our work. So let me quickly introduce who we are. So on the left, you see our core team. So today you will hear from me and Mehdi. You just heard from Florian, who is our boss. We are research software engineers based in Human Technopole in Milan, and we are the core of the team working on this project. We also received huge, enormous amounts of help from Joran and Damien, who are the part of imaging facility here in Human Technopole. So they helped a lot with organization, selecting the projects, reviewing the projects, mentorship, everything. And hopefully they took a lot of lessons that we learned into running their bioimage facility themselves. And finally, we have Eduardo, who is postdoc in the group, and he helped us a lot during the preparation of the public challenges. But it also couldn't happen without the experts and reviewers who were volunteers from our partnering institutions who helped us review, select projects, and ultimately provided their expertise to also work on the selected projects. So I also wanted to say huge thank you to them all. So what are we going to talk about today? So in the first part, Mehdi will tell you about the open calls. He will tell you how we organized a series of open calls where we asked bioimage analysts and just people from the large bioimage community to submit to us the problems that they think are solvable through deep learning. So he will tell you about what questions we ask them in applications, how we reviewed the applications, how we chose the right projects, and how we ultimately help them and try to set them up for success. And then I will tell you about the public challenges. What are they? How we picked the themes and um, problems for them, and also where we hosted them, and what it really takes to organize one, if you're interested in that. So now yeah, so Mehdi will talk to you about the open calls.
Yeah. Hi and welcome everybody. So I'm gonna talk about 3 years of open calls and the process that we had for selecting projects and the evolvement of this process. So basically, why we do open calls, why we did open calls, beside that it was part of the AI for Life grant, but also the main purpose was to connect the bioimage analysis community with the computer scientist community. So these are two very specific expertise, and it's quite rare that you find someone that is a expert biologist and also expert in deep learning and computer science. So we need to somehow make a team of both parties and to solve the bioimage problem and challenges with AI and deep learning. So that was the main purpose, and to uh, narrow the gap between these two communities. One way was to have these open calls so people could bring their challenges, their problems to us, and we can make at least a temporary team with two different expertise and try to solve the problems for them. And of course, the one of the challenges that I will talk about it later, it was about to justify the expectation from AI, and to also because usually in the bioimage analysis community, when they come to us with their problem, they expect a clear, easy solution, and it's not achievable usually without having good data. And it's a important thing that before applying for open calls, you need to have enough data, clear, high quality data, and ground truth. So as for the first open call, we started with a simple form, and not very simple. It was a bit long, and because we needed to get as much as information we could from the user about the application, about the challenge in the form. So we designed this form, and we asked about image data, like the format, is it TIFF, ZAR, whatever, or 2D, 3D. Also about the current workflow that they are using, and what are the like challenges of this current workflow, and something that they cannot solve it with this available workflows. And so after the application process, and we received a bunch of application, then the selection process began. And first thing we did like a sanity check, or what we call it eligibility check, which basically we removed those applications that the form was not complete, or I don't know, maybe some cat just walked over the keyboard and sent us the application. So we removed those, and then after we started the reviewing process, we asked our colleagues in different institute, AI4Life colleagues, and also some external reviewers. And we reviewed for each project, at least we had 3 reviewers, and we asked them to um, kind of give a score for different questions, like if the goals are cleared and well defined. And also we were much interested in projects that we could use deep learning, not classical machine learning or classical bioimage analysis. So that was also a priority for us. And also we wanted to not just solve one limited project. We wanted to have this project as an example, and then later we could publish this workflow and pipeline, and other bioimage analysis could use this pipeline for their problem as well. And at the end, after the reviewing, we calculated a score and a score for each project. It was a bit complicated, and the score was weighted average of some other some like fields, and it was a bit difficult in the beginning, because most of those score was like qualifying score, and we need to change them into numbers. And finally we got the score for each project, and based on the rank of sorting those scores, and based on the rank of the project, we select um, 8 project for the first open call. And so, yeah, for this open call, we received 72 applications. We selected 8 projects at the end, and all of them are done. And you can check the pipelines on our GitHub repository. And also, we submitted 6 data set to the Bioimage archive, and also 5 models to the Bioimage Model Zoo for this open call. So on the second open call, we made some changes. So first of all, the main challenge for us was about selecting the right projects. What we learned from the first one, we understood that just relying on the form of the application, uh, and also scores that reviewers gave to the projects. It's uh, not always represent a good project. It's much more complicated selecting right projects. Sometimes after the selecting project, we realized that data wasn't that ready, or the amount of data or ground truth was not ready. So we decided to make some changes. Um, so we refined the form. First, we kind of remove some of the questions and clarified some other questions. Also, we asked users to upload some data for us along with the application form. And also, we gave them some template for presentation of the project, and we asked them to fill that template with their project information, goals and challenges, current workflow. And so with this template, with this presentation, we could just, for our reviewers, it was much more easier to just look at this presentation and uh, make a decision about the applications. But one of the pinpoints of this series of open calls was about consultation. So from the first open call, we received 72 applications, but we ended up with only 8 projects because we have this limited manpower and time. So, but a lot of those projects also could benefit from some at least direction of given by us, given by computer scientists experts. So we added this consultation phase after pre-selection, and in this phase we asked the pre-selected project to book a 1 hour time in a almost 2 weeks range, and we had this one-to-one meeting with them. I mean, at least 3 experts were present at the meeting, and we asked them to present us their project based on the template project that they sent us. And we then on that meeting, we could ask more questions to clarify the project goals. We were able to see the actual data. We asked them to open the data in Fiji or whatever software they are using, and it gave us a much more realistic view of the application. And also, for those projects that they weren't qualify as a like a full-time deep learning project, but they could benefit from us to give them some advice, some direction to use these tools or this pipeline. There are many tools and pipelines already available to solve their problem. So, but they didn't know. So this consultation helped them a lot and helps us a lot, of course, for the make a better selection. And so, yeah, obviously, this was a pinpoint of our open calls selection process. And so for the second open call, we received 51 applications. We gave 20 consultations, and at the end, we selected 7 projects. And also, as the first open call, we have the pipelines, and 3 data sets were uploaded, and more will be uploaded soon. And for this third one, basically based on the good experience that we had from the second one, we continue that line, and we just polished a bit the form, and for making reviewing even more simple, we put some clear questions for reviewers, and we asked them to give a score directly instead of like a comment or something like this. And so in this way, we could calculate a score more easily. We had this excitement score, which was, I guess, Florian's idea. Basically, it was about to how we are as a reviewer or someone that potentially want to do this project, excited about this project. We wanted to do something new and also useful for the whole community. So basically, we had this scoring, and we did the consultation as well. Unfortunately, we had some of the users that were selected for the consultation didn't contact us and respond us. But for this third open call, we received much less applications, but I would say the quality and they were more ready to be solved by AI and deep learning. They were more deep learning ready. Um, so I guess after 3 open calls, we learned our lesson, but unfortunately, this is the end of this series of open calls. And for the third open call, we had 28 applications and we gave 10 consultations. We selected 7 and they are ongoing, almost done. Some of them almost done, are done, and hopefully we will finish them probably in mid-September. So yeah, these are some of the these are 8 projects we had on the first open calls. You can check them on the AI4Life Urban Imaging website, and for also for other open calls we will put this use cases as well. And so this one of the first open call projects, and one of the, I would say, most successful ones. We made a tool for this project, and they didn't have any grant rules for segmentation, and we made this tool. We call it Feature Forest, and they used that tool to make a segmentation very easily instead of doing fully manual work, and they managed to publish their work using this tool. So after all of 3D open calls, we learned some lessons. We had some struggles, some challenges. First one was this about qualification of the application, how to select the right application. It was very challenging, and we evolved the selection process during these 3 years. And in the end, we end up in a good place. And as I mentioned, the consultation was very helpful and great idea. Also, another problem was about this justification of what AI and deep learning can do for those applicants and users. Sometimes they expected like a magic or something like this from us, and we should we we had to talk to them and tell them that if your data is noisy, is or not enough, or if you don't have any ground rules, then we cannot do proper deep learning for you. Data transfer also was one of the main issues for us, especially for the first open call and partially second one, uh, because usually the problem um, came with a lot of data, like gigabyte or even a terabyte data, and it was very hard to transfer this. Each institute has this their own like a way to upload data, and uh, matching these different servers, and it was very difficult. For the first open call, we had 1 terabyte data sent to us with on a physical hard drive via post. So it was a bit challenging, but I would say for the third open call, we didn't have this issue, and it was very smooth for the data transfer. Uh, After the project, we finished the project. The main important part is to transfer this pipeline and the installation and the requirement to the user. And usually it happens during an online meeting, and it's a bit challenging to help them to install Python and different packages and fix the errors for them. Um, but yeah, it depends, very depends on the user. Sometimes they have some support, or they have some knowledge of installing Python and packages, and it for those it's much more easier. Sometimes we had these vacations or some delays in communications, and it was sometimes uh, we waited for some response for weeks, sometimes, or vice versa. They sent us a file, but uh, we were on holidays or vacation. And at the end, also, one of the our obligations was to upload data publicly, make them publicly available for the community for each project. And sometimes we had this hesitation from the user that they were worried about making the data available publicly, and then maybe someone else's can use this data and publish the papers before them. And yeah, that was also some kind of a struggle for us to make them sure that it won't happen, or at least we can upload a smaller portion of the data and without problem. But on the other side, we had very uh, delights, and many good things happens during these 3 years for us. um, we learned that this consultation would help a lot, um, not just for the selecting the best projects, but also for those users that receive this consultation. Three experts in bioimage analysis and deep learning having a 1 hour meeting with the user, and we could help them a lot and introduce them the potential solutions for their problem. And this consultation was very useful for everybody. And also making connections with different biologists, different community across the world also was a delight for us, and we learned a lot from them. And it was very uh, pleasure, and for me especially, it was very nice to learn from each project. I learned a lot. And so at the end, having the delivering the solution to the users and seeing them, they are happy with the solution, and they can move on and write a paper and doing their own expertise stuff, and not to be worried about this part of the computer scientist stuff. It was very joyful for us. I guess I'm done here. Yeah.
Thank you. So now I will talk to you about the second half of our work, which was organizing public challenges. So if you never interacted with deep learning competitions or similar things, I will quickly get you up to speed. I will introduce one of the challenges that happened in the past, and I think it was pretty influential in the community, and hopefully you'll see why organizing some this stuff matters. So in all the way back into 2018, um, researchers identified a task. So can we automate the process of identifying nuclei on microscope images? So in collaboration with Board Institute and they collected a data set that I think was one of the first of its kind, where they imaged nuclei in different scenarios on different samples, and they also provided segmentation for each of them. So they partnered with Kaggle. Kaggle is the platform that is the most famous for their deep learning competitions. They host competitions in wide variety of fields, in medicine, in satellite imaging, in self-driving, in biology also, so and everything between. They provide infrastructure and also they have a very active and vibrant community of people who specialize in deep learning. So this competition gathered a lot of attention. It gathered around 1,000 participants and also 2,000 submissions. What's the main thing about such competitions is that everyone receives the same data set, so everyone can try to train their deep learning on the same data, and then everything gets evaluated and benchmarked on the same hidden set of test data. So people can compete against each other and see how different deep learning algorithms compare and see which approach is the best one for a given task. And now we can see the impact. So it allowed, so the proceedings from this challenge, also the data set was reused in many papers, and it allowed for tools like Salpos to be created. So Salpos currently, I think, solves the question of identifying nuclear and microscopy imaging in the many common cases. So as you just run it and out of the box, in many, many cases, it just works. And back in 2018, they introduced this task as being very difficult, very um, innovative, and currently it's pretty much solved as the impact from this challenge. So when we decided, also one example of how we use the Salpos in one of our open call projects. So here we identified nuclei and segmented them automatically using Salpos, and then we tracked each individual cell in time using TrackMate. So we can see how just back in 2018 it was something very ambitious, and now it's just works in the bioimage analysis pipelines. So when we decided to embark on the project of creating our own challenges, we thought that, okay, we will receive a lot of applications from open calls. We will scout which problems are the most painful for bioimage analysts and for researchers. And we will also get great, large, very quality data sets that we can just directly funnel into creating public challenges, and it will all be awesome. But of course, it didn't happen as we envisioned. We indeed got a very good sense of what problems are there in the community, but we never received a data set that was big enough and also had enough quality, and also didn't have enough annotations that it can just be directly funneled into creating a challenge. So we saw when solving the projects that a lot of them boil down to a pipeline very similar to this. So first you do some kind of image preprocessing, then you segment your target structures, and then you do some kind of downstream processing and analysis. So for the example that I showed you before with the cell tracking, first we denoised the videos, then we segmented the nuclei using Salpos, and then we did some downstream processing with TrackMate to get the final result. So we started thinking about how can we improve any of the steps of this pipeline, being it very common in the projects that we received. So as I said, segmentation pretty much works out of the box for common cases right now. Downstream analysis is very, very task specific. So for each and every project, it's pretty much unique, and you cannot formulate it broadly enough so it can be made a challenge. But what we realized is that for several projects, we use denoising as the first step. So denoising allowed us to improve both segmentation and downstream analysis quality. But there are different denoising algorithms, and also we didn't have good information about how they all perform on different kinds of data. So what we decided to do is that denoising methods need systematic benchmarking and comparison. We decided to gather different data sets with different samples, different modalities, and see how different denoising methods perform. So it could be something interesting for the deep learning community to either implement existing denoising methods or maybe even create novel ones and then compete on a leaderboard to see which one is the best. To create the challenges, we partnered with Grand Challenge. It's a European platform that specializes in challenges in mostly medical imaging. Um, they have a really nice community of people who take part in such challenges. They provided us with great technical support. And they also implement all of the features that you would expect from a platform that allows you to run some challenges. So they do the algorithm validation and comparison for you, and they support the algorithm submission process through Docker, which I think is awesome because it makes the solutions reproducible. So we partnered with them, and I think we didn't regret it. It's a very nice platform, and if you are thinking about organizing something like this, I can really recommend them. So the process of organizing the challenge looked a bit like this. First, you need to define a concrete and achievable task. I think this is the most important step. You need to be able to define a task that you can explain easily to a person who has no background on biology and is just interested to apply their deep learning knowledge to your problem. Then the next step is selecting the appropriate data sets, whether you emit your own or you just gather something from the existing databases. It's you need to make sure that the data that you select is representative for the task that you set up. Next, you need to prepare the comprehensive documentation for the participants, detailing why you organize the challenge, what is the problem, and what are the algorithms currently, maybe pointing them to some papers and motivating them basically to join your challenge. And you also need to provide the starting code. And also, many people still don't know how to use Docker, so you also need to provide the instructions how to package their code to then submit it to the platform. And of course, you need to be on the lookout for the questions from the participants and provide them with ongoing technical support on how to do different steps and also how to debug their containers, how to submit their containers. So it's also very important. Like this, we were able to organize one challenge in 2024 and two challenges now in 2025. So the challenge that we organized in 2024, we gathered 4 data sets and 4 leaderboards. We received 150 submissions from more than 100 participants from all over the world. And I think it was pretty successful. The second challenge is still running now, so it's until August 31st. It's focusing on supervised microscopy denoising, so it's, I think, more kind of easy to get into if you want to learn some deep learning, or maybe you just want to apply some knowledge to data set. So it's open till August 31st, and if it's something that is interesting to you, I really encourage to check it out. And currently, we also have the third challenge running. So this one is a bit more niche. It's focuses on calcium image denoising, but calcium image denoising was coming up in our applications and also in the courses that we run. A lot of people need this, and a lot of people will benefit from this. And I think calcium denoising, it has its own set of quirks and problems, and I think it's really exciting personally. So if you think it's something interesting to you, I also really encourage to check it out. You can find this on our website, and also you can find these challenges on the Grand Challenge. You can look for them using AI4Life name, and you'll find them. Okay, so summarizing all of what we said so far, for the open calls in these 3 years, we received 151 applications from all over the world. We performed 30 consultations with a set of experts from many institutions across Europe. We selected 22 projects to help part-time for free. And we organized 3 public challenges. So what we get from all of this as free accepted publications right now, and I hopefully some more will come up afterwards, where people use our pipelines in some way to do their research and then getting the results. We developed one tool that Mehdi presented to you, which does segmentation in 3D. It's called Feature Forest. You can also check it out on GitHub. And yeah, you can also see the results and the pipelines that we came up with during open calls on our GitHub. And also you can find everything on our Eurobioimaging website. But you may ask, well, open calls seem awesome. How do I apply? How do I get help? Unfortunately, our job is over with this project, but you can get help first using Eurobioimaging nodes. So Eurobioimaging have nodes in many European countries and many locations. They provide help for a price, but they can provide you with bioimage analysis tools and help, and with very good quality, and we really recommend them. Also, the next is GloBIAS. It's a global bioimage analysis society. You can of course, check it out and find a bioimage analyst to collaborate with, or maybe find someone that can help you with your projects. Then we always recommend having a look on ImageSC forum, which is really active and really helping a lot of people. You can find help with bioimage analysis tools, or even detail some problems that you have with your data, and people are super helpful there. And the last one, Caterina will talk to you about the Bioimage IO chatbot. So chatbot is a new novel way using large language models that also can help you with your bioimage analysis questions and worries. So with that, I want to say thank you and give word to Caterina.
Such a nice introduction, Vera. You really nailed it. Thank you. So I'm gonna try to be fast, so we have time for some questions for Mehdi and Vera, who did such an amazing work. I participated also in the open calls as reviewer and all, and it's been really amazing. So let me share my screen, see if this works. And yes. So as this is GloBIAS, we wanted to make something short for the biomaterial chatbot, because I already gave a talk, a full talk, like a 1 hour talk about the chatbot, how it's used, and I even included some demo. It's in the YouTube channel of GloBIAS, so you want the whole thing is there. So basically, for the people who don't know what the chatbot is, it's what Vera said. It's an LLM that will help you through the bioimage analysis. Not only how to analyze images, but we can even analyze images with cell pose, and you can also query models and all, because it's connected to the bioimage model, so which makes it very special. So this is like in the big picture. Basically, the biomaterial chatbot was born due to the challenges in bioimage analysis. I guess that everyone uses here ChatGPT for their work every day. So we thought that maybe we could do something more precise in order to help users to navigate the bioimage analysis world, and also to help users with the bioimage model zoo. So we noticed that normal LLMs, such as ChatGPT, sometimes they can be very imprecise and they can have even what they are called hallucinations, in which you get wrong answers to your questions. So this was one of our major concerns, the information that was given to the users. Then then we can say that in the bioimage analysis, we are very lucky because it's an area where there exist a lot of different tools and a lot of different ways to do similar things, but it's full of different tools, so full of different types of documentation. And going through all of these and read all the documentation would be almost impossible. So a way to gather all this information is also what we needed. Then there is also a knowledge barrier in artificial intelligence, as already Mehdi told, that sometimes in the open code, people, as they don't have notions of artificial intelligence, they expect that artificial intelligence might do magic over their images, which is not true. We needed to tackle these too. And also, we lack the tailored support for bioimage analysis tasks in a more automatic way. So for this, we created the Biomagia chatbot with, it was me, together with Wanlu and Wei from KTH, and also Gabriel Reader, and also Arrate, which I think she is in the audience. She is my boss. So we created the chatbot and we did some promotion on using it. Basically, what the Biomagia chatbot does is that it's such an LLM that you might used in the past, in which we get something extra in order to tailor the responses more for you. What we get is the user's profile that you can enter if you want, use the user's query, and also conversation context. This way, our answer will be more precise, the more as precise as possible. And the user profile, you can say, for example, which is your background, and so we get more information. The specific or more special thing about the chatbot is that what we haven't done is to retrain an LLM. So you can see that a lot of people, in order to have certain documentation or certain information, they get an LLM, maybe a public one, an open source one, such as Llama, or a private one, such as GPT, and they retrain it with information in order to give support to people. But instead of doing this retrain, what we did was to make some technology that what would do was to retrieve the information. So instead of retraining and making the chatbot know about this, we would make the chatbot go to the actual documentation of each tool or what the information that's given in that moment and retrieve the information. This way, what we avoid is these hallucinations, these misconceptions, and this loss of information, because this was and has been always our main goal. Apart from doing the retrieval of information from documentation and so, you can also do code generation and execution. The chatbot is mounted in different assistants, so each assistant does a different type of work, and you can ask different types of questions and help you in different type of areas or so. The chatbot is able also to do web browsing. So sometimes if it's not sure, if it doesn't have the information, we'll do web browsing, but always making sure that it's some information that is about the bioimage analysis and checked with the information that it has. So we don't have this kind of hallucinations. It has some general knowledge coming from the GPT. And then there are more stuff to come, because what we're always open is to add new tools to the documentation. So if you are a bioimage analyst and you have a tool, you could embed your documentation into the chatbot. So users can use the chatbot to read your documentation, read or access your documentation. And these are things that can be growing in time. So basically, this is an example of the personalization that I was telling you before, that what we do is that, as I always say, we don't usually trust people with prompt engineering, because sometimes people uses LLMs as if there were their Google search bar. So what we do is to try to tailor a bit these questions so the information that is given to the user can be more precise. For example, we ask name, which is just politeness, but then occupation, background information, and all. the query that is the user is asking, the past conversation, and also sometimes, well, what we usually do is to generate a preliminary response and use this also as context. So if the user has maybe asked the question in very specific words, but not in a real answer, unreal question or so, this would serve as context for the information. And then you would have the chatbot that would answer your question. As I said before, we do this documentation retrieval. We are able to retrieve information from different documentation tools. We have access to image documentation, of course, the bioimage model zoo and all the bioimage model zoo models, meaning that if you want to use a model from the bioimage model zoo and you don't know which model to use, you can ask to the chatbot, for example, I have this type of images. I would like a model for segmenting my cells, which is this type or whatever, and it will recommend you the best model to do that, more or less filtering the tags that the model has. Um, then also embedded documentation of the DPMJ, of BioTools, Elastic, Enjoy, and others. All the information is stored in the vector database. And again, what we're doing is to retrieve that information. Also, we have access to the biometric models, I was saying, and we can do code generation and execution. And you can even do cell posts. You can even upload an image. You mount a space in your browser, you upload an image, and you can do cell pose, just a simple cell pose segmentation over one image in your browser in a moment there. It's very, very useful. Again, we're browsing the general knowledge, and again, more things are also coming. The ways to access the bioimage model zoo are through the bioimage model zoo, in which you can access there through a window. You can access directly, which is the preferred way, the bioimage model zoo chatbot. Sorry, I've said the bioimage model zoo. I wanted to say the bioimage chatbot. You can access there, and you can access also the assistants from there, so it's very easy to do it. And also you can access it through ChatGPT store. If you go to the GPTs of your store, you can type bioimage.io chatbot and you will have it there, and you will have direct access from there too. But you cannot choose assistants. You would have the basic one, which is to retrieve documentation. And as we were working this presentation as lessons learned also from open calls and projects and all, I've included here some lessons that we have learned through developing the biomagia chatbot. And the first one was one of the, I think, one of the most useful ones, because it's the most important thing how things are evolving, is that improve your documentation to be self-contained and very, very efficient. So if you have a tool and you have documentation of your tool, try to be very self-contained and explicit on what you want to tell and everything. Because what we're doing is to retrieve information, and the more precise this information is, the better the chatbot will work. And I see that people every time is less using the documentation itself. For example, I have students and I'm trying always to have them consult the Python documentation, but they only ask to ChatGPT. So with this, I mean that the better the documentation is, the better the responses will be from an LLM. So that's for me one of the most specific and more for the one of the goals of this. Then work on prompt engineering. Again, asking something to a chatbot is not your Google search bar. Be precise in what you need. Ask to the LLM exactly what you need. Give details of the context, what you're doing, on the images that you're using, or which is the goal that you want to achieve. Be precise. Don't just look for an error. Try to explain why are you doing that, and this will work much better, I can promise. And then the other thing is that, should we do a documentation of the chatbot? We have some, but we're not usually giving it, because if you have questions about the chatbot, you can ask to the chatbot itself. That's why it's very useful. And basically, this is everything from my side. We have 5 minutes for questions or more. I don't know, but thank you.